Hello students, today we are going to see stack, queue, trees and graph. This is basic intro of four we are going to see. What is all these four: stack, queue, trees and graph? These are the four core data structures that form the building blocks of computer science and AI system design. Okay, this is a very important topic. Please listen to the video fully. Okay, now first, data structure. One is stack. How it organizes data? It's a vertical list where items are added and removed from the top. Okay, last in first out is the key principle in this. Example is, if you are arranging books, what you will do, you will have to pick up the last book that you have placed. Okay, that is stack. Second is queue. Queue is a horizontal list where items join at the back and leave from the front. This is FIFO, first in first out. A ticket counter, cinema ticket you would have booked, where first in first out is the principle. Third is tree. Tree data structure is hierarchical data structure, starting from a single root and branching down to children. Parent-child hierarchy. A family tree or an org chart is an example, real world example. Fourth one is graph. These tree and graph you will understand in the next section, where I'll show it in a picture. Next is graph. Nodes, network of nodes connected by edges in any pattern. This is graph. Network connections, how it's multiply connected, is shown in this graph. Okay, flight path between cities, social networks are real world examples. Now, actually, we will see this image, you will clearly understand. First one is stack. Stack is you put items like this, and the last item is what you take out first. Last in, first out. When you arrange books and you will have to take it, you will have to go by this. Second one is queue. That is first in, first out. Queue is first in, first out. You enter like this and come out like this. This is NQ, DQ. Okay, this is a way out. First in, first out is the tree principle in this. Third is tree. Tree is where there is one root node and there are children. Okay, this is a parent, and then it comes root, parent and child. Root, parent, child. Okay, so one root is there, only one. Okay. Fourth one is graph. Graph is N1, N2, N3, N4, N5. All these can be interconnected in any way. That's why it's called a network of interconnected nodes. It's called vertices. And the relationship between two nodes is edges. Like to a Google map, road map you have seen in your mobile, it is a graph. Okay, so the difference between a tree and a graph is tree has a single starting point as root, and it goes only one way. It's not interconnected as graph. Okay, so now we look at the next point: linear versus non-linear. Data structures are grouped into linear data structures, non-linear data structures. Example of linear data structures is the first two, stack and queue. Data elements are arranged sequentially in a single order. You process items step by step, either LIFO or FIFO, which stands for last in, first out, and first in, first out. Second is non-linear data structures, where trees and graphs are examples. These data structures are arranged hierarchically or interconnectedly. One element can link to multiple other elements. This is non-linear data structures. Why do we need this? This is what is important now. Now we are going to see what is graph theory. Why do we need to learn all these data structures? Okay, graph theory is a math of connections. See, instead of focusing on isolated numbers, plain list, it studies how things are related to one another by providing a map as a network. Okay, why do we need this graph theory? Why do we need to know graph theory and graphs to learn about AI? Okay, till now we would have seen in traditional computer systems, till now before AI, we would have seen data in tables. You would have used MySQL, SQL Server, Oracle database. All those are there. Okay, these are like spreadsheets, and data is arranged in which way? Rows and columns. You would have seen an Excel sheet. Same thing. It will be in rows and columns. But in AI, it uses graph neural networks and knowledge graph. This is very important. You will have to learn GNN, graph neural networks and knowledge graphs, because the real world is interconnected. Next section, I will show you an example. It is easy only. Please don't be afraid. Okay. See, the understanding of context requires mapping how it affects the relationship, how it influences the relationship, is what makes this possible. Now, what are knowledge graphs and GNN, graph neural networks? Both these knowledge graph and GNN are modern technologies designed to work in an interconnected way using relational data, but they have a specific role for each one. Knowledge graph is actually like a table, but it structures data in a different way so that it can retrieve and reason over relationship. So all this looks confusing, right? Now let's look at an example. You will understand clearly. Supposing you are going to Amazon website, you would have gone there and did lot of shopping there. Supposing you are looking at a mobile phone, you want to buy a mobile phone. Automatically it shows products from other brands. You want to buy a Samsung phone or Apple phone, it shows other products that are there below from other brands, and the items that you may want with the current purchase. Supposing you are planning to buy one mobile phone, it will show other brand mobiles below. Also it will show cover for it, it will show glass for it, wireless headphones it will show, charger it will show. All these products are shown in the page, right? How is it possible? Because mobile phones and charger, glass, mobile cover are all interrelated. That's the key. They are all related, and all these are represented by knowledge graph. Please know, knowledge graph collects related items and save it as a set of items. So when you look for mobile, automatically cover, glass, accessories, charger, wireless headphones, all these come with it. It shows, right? This is possible because of knowledge graphs. Okay, so it's simple, right? So this is what is knowledge graph. It's a related items are grouped together and saved together. So number what we have been used to is we have been used to rows and columns, but here it shows saves it differently. Knowledge graph saves it differently. Okay, now second is graph neural networks. Now what is graph neural networks? These are machine learning algorithms. ML you would have heard. So these are algorithms for machine learning that process graph structured data. Before we saw knowledge graph. To process it, we need GNN. Okay, to learn patterns, predictions, and discover hidden connections. Okay, now from the knowledge graph, from the user base, it understands the patterns, what is happening, and it will make predictions and discover hidden connections that are there. That is graph neural networks. This is part of machine learning algorithm. Okay, now we look at an example, it will become easy for you. Okay, what is an example of GNN? Financial fraud detection. See, we would have known, we would have heard a lot of bank money from mobile is hacked and money is taken from the account. All these stories you would have heard. Okay, now what globally they are doing is they are implementing GNN AI in banking systems so that when a scammer, what do they do is they take the money from A account and move it to B, and dozens of account they transfer the money. Okay, they try to take money from account A, move it to account B, and then they distribute the money, split the money into dozens of intermediate accounts. That's what these people do, it's the scammers. So GNN, what it does is it analyzes the entire network structure. What we see is from account A it goes to account B is what we see. But GNN, what it does it looks at the entire structure, network structure, and sees all the transfers that are happening, and it flags the hidden pattern and blocks the account in real time. So they looks at the pattern and blocks the accounts in real time. Immediately it blocks it. So this is becoming possible because of GNN. And down the line, probably couple of years, we should have this everywhere. Okay. So this is again possible by GNN, and this example will help you understand what GNN is. GNN uses knowledge graph. Knowledge graph is actually storing and organizing structured data. Okay, hope you understood. Now, today what we have seen is there are four data structures we have seen: stack, queue, trees, and graph. Okay, and then what we have seen: linear and non-linear. Okay, then what is graph theory? Then why do we need graph to learn AI? This is the important question. Why do we need to learn graphs? Yeah, so there are two things in this. One is knowledge graph, second is GNN. So these two, how it's implemented, I have showed you. One is for using Amazon website, second is financial fraud detection. Okay, So you understood what is happening in using graphs, how we are using knowledge graphs and GNN. Okay. So this is a basic data structures, and why we need it for learning AI is this. Okay. Hope you understood. If you have any doubts, please ask me. Please subscribe to our channel so it will help us. Thank you for watching.